Hi everyone, welcome to the channel. In this video, we'll learn about the symmetric cipher model, the characteristics of cryptographic systems, and also about cryptanalytic attacks. So first, let's learn about symmetric cipher model. What is the meaning of cipher? Cipher means it is also called encryption algorithm. Encryption algorithm or a crypto system is also called as a cipher. And one type of encryption scheme is called symmetric encryption. Symmetric encryption is a form of crypto system in which a single key will be used for both encryption as well as the decryption process. We also call it as conventional encryption or single key encryption. So here in symmetric encryption, the plain text will be converted into ciphertext using a single key and an encryption algorithm. So let's learn about some basic terminologies which we'll be learning in this cryptography and network security course. First is plain text. The original data which we want to convert is called as plain text. Second terminology is ciphertext. Ciphertext is the scrambled message which we are going to convert from the plain text is called ciphertext. Third one is cipher. Cipher is nothing but the encryption scheme which we are going to use for transforming the plain text to ciphertext is called cipher. Fourth one is key. Key is nothing but a secret info which is going to be known only to the sender and the receiver. Next one is encipher. Encipher means the process of encrypting and decipher means the process of decrypting. And what is the meaning of cryptography is cryptography is that area of study in which we are going to study about the different types of schemes used for encryption of the plain text. And next one is cryptanalysis. Cryptanalysis means usually the decryption of the ciphertext will be done using the key. But whatever techniques we use, when an analyst tries to decipher the ciphertext without the knowledge of the key, is called as cryptanalysis. So cryptanalysis is nothing but code breaking, where without using the key, he will try to find out the plain text from the ciphertext. And you also have cryptology. Cryptology is the area of study of both cryptography as well as cryptanalysis. Next is the symmetric cipher model. You can see this is the basic symmetric cipher model where the input is your plain text. The plain text is nothing but your original message, and the plain text or the original message is fed as input to the encryption algorithm. Encryption algorithm may be anything like the DES algorithm or the triple DES or the AES algorithm, etc. So the encryption algorithm takes the plain text as well as the secret key as input. So the encryption algorithm performs various substitutions and transformations on the plain text. The secret key. So here we have something called as a secret key, which is known only to the sender and the receiver. The exact substitutions and the transformations which is used in the encryption algorithm depends on the secret key. Okay, so the key is used as input to the encryption algorithm, and the encryption algorithm will produce different output for different keys. And as a result of the output produced by the encryption algorithm is called as the ciphertext. And this ciphertext will be in turn applied to the decryption algorithm. The decryption algorithm is nothing but just the reverse of the encryption algorithm, which in turn will make use of the same secret key which is shared to the receiver, and which in turn will produce the plain text as output. Here your ciphertext is nothing but your scrambled message. So basically, there are two requirements for the secure use of symmetric encryption scheme. As I told before, it is all dependent on the encryption algorithm and the key. Encryption algorithm is not going to be kept secret, but the key only is going to be kept as secret. And it's going to be known only to the sender and the receiver. So encryption algorithm is going to be known to everyone. So it has to be as strong as possible. So even if the attacker, even though the attacker gets hold of the encryption algorithm, he should not be able to decipher the key or the plain text. And the key has to be kept secret. So for that, if the key is generated by the sender, it has to be securely transmitted to the receiver, or a trusted third party can be used to generate the key and send it both to the sender as well as the receiver. So mathematically, you can say y is equal to then if we apply the encryption algorithm, let X be the plain text. Encryption algorithm is applied on the plain text as well as the key K to produce the ciphertext Y. And at the receiver side, the plain text X is obtained by applying the decryption algorithm. Here, the decryption algorithm is denoted as D, and the decryption algorithm is applied on the ciphertext Y and the secret key. So next is about cryptography. What is the meaning of cryptography? Cryptography is the area of study where we are going to study about the different types of schemes used for encryption. So such cryptographic schemes are characterized along 3 independent dimensions. First is the type of, depending on the type of encryption operations used. So it may make use of substitution or transposition, or you also have product systems. Substitution is nothing but when each element of the plain text is mapped to each element of the ciphertext. Each element or bit or group of elements in the plain text is mapped to group of elements in the ciphertext. It is called substitution. Transposition is another scheme wherein it is obtained by rearranging the elements of the plain text. Product systems will make use of many different rounds of substitution and transposition techniques. Second is based upon the number of keys used. Cryptographic systems can be classified as single key scheme or 2-key scheme. Single key is also called private encryption and private key, and 2-key is also called public key. So here in single key, it makes use of one secret key is used by both the sender as well as the receiver for encryption as well as for decryption. The third one is the way in which the plain text is processed. Depending on the way in which the plain text is processed, a cryptographic system can be classified as block cipher and stream cipher. The meaning of block cipher is, in the case of a block cipher, the input will be processed as blocks at a time. So input will be fed to the cryptographic system as one block, and the output also will be obtained as one block. And in the case of stream cipher, it will process the stream of elements continuously, and the output will be produced one element at a time. The next is about cryptanalysis. So cryptanalysis is nothing but when an encryption algorithm is attacked. When an analyst attacks the encryption algorithm and tries to exploit the characteristics or properties of the encryption algorithm, it is called as cryptanalysis. So typically the motive of the analyst will be to recover the key rather than simply discover the plain text associated with a particular ciphertext. And there are 2 approaches which is commonly followed for this cryptanalysis. One is cryptanalytic attack and the other one is brute force attack. In cryptanalytic attack, it basically relies on the nature of the algorithm plus some knowledge of the general characteristics of plain text or knowledge of the simple plain text ciphertext pairs, some sample plain text ciphertext pairs. So basically the cryptanalytic attacks will exploit the characteristics of the encryption algorithm to deduce a specific plain text or to deduce the key which is being used in the encryption process. And the second type of attack is the brute force attack. Second approach is brute force attack, where every pause is to try every possible key on a piece of ciphertext until an intelligible translation of the plain text is obtained. So on an average, if you follow this brute force attack, half of all the possible keys must be tried to achieve success. So in either way, whatever approach is being used, if success is obtained in finding out the key, then all the future and past messages will be compromised. The next is the different types of cryptanalytic attacks. First is the ciphertext only attack. In the worst case, the analyst or the attacker might know only the ciphertext, and sometimes the encryption algorithm also might not be known. In this case, the analyst may try to use brute force approach on all the keys. He may try to use all types of keys or all possible sets of keys on the ciphertext and try to find out whether an intelligible translation of the ciphertext into plain text is obtained, or he may try to perform a statistical analysis of the ciphertext and try to deduce the key or the plain text. The second type of cryptanalytic attack is known plain text attack. So in this known plaintext attack, the attacker might get hold of some plaintext ciphertext pairs, one or more plaintext ciphertext pairs. Along with, he may also have possession of the ciphertext and the encryption algorithm. So in this case, based on this knowledge, he may try to find out the secret key. And here in this case, the attacker must have, say for example, if it is if there is a document in PostScript format, it will be following a particular pattern. If there is a message for an electronic funds transfer, there will always be having a standard header for it. So based upon that, the attacker may try to deduce some patterns in the ciphertext and try to find out the secret key out of it. So in this situation, the attacker must have some knowledge about the plain text, which will be hidden in the ciphertext. So so whether it is a Java source code, or it might be a accounting file, or it might be an accounting file, or it might be an exe file, something like that. The next one is chosen plain text attack. In the case of chosen plain text attack, the plain text message chosen by the cryptanalyst will be somehow injected into the system together with the corresponding ciphertext generated with the secret key. So with that, by having this chosen plain text, the attacker will try to find out what type of ciphertext it is producing, and by that he may try to deduce patterns and the secret key. Similarly, so the next one is chosen ciphertext attack. Here, the attacker, the cryptanalyst, will make use of the ciphertext which is chosen by him and inject it into the system and try to deduce the secret key. The next one is chosen text attack. Here, the ciphertext as well as the corresponding decrypted plain text, everything will be chosen by the cryptanalyst. He will try to inject it and try to deduce the secret key out of it. So based on this, we have two important definitions of encryption schemes, namely unconditionally secure and computationally secure. An encryption scheme is said to be unconditionally secure. So you have the ciphertext. So how much ever computing power or time is available, if the ciphertext does not contain enough information to find out the corresponding plain text, then such an encryption scheme is called as unconditionally secure. So far, the only encryption algorithm which is said to be unconditionally secure is the one-time pad. Apart from this, with the exception of this one-time pad scheme, no other encryption algorithm is said to be unconditionally secure. So there are two criteria which has to be met by an encryption algorithm. One is the cost of breaking that encryption scheme must be greater than the value of the encrypted information. The cost must be higher. And the second one is the time required to break the cipher must exceed the useful lifetime of the information. So with this, we get the next definition of our encryption scheme. An encryption scheme is said to be computationally secure if either of this foregoing criteria, either of the above two criteria is met, then it is said to be computationally secure. The cost of breaking the cipher should be higher, or the computation time required to break the cipher should be more. So, but computing the cost of breaking the cipher is generally very difficult task. So we have always been learning about brute force search. Brute force search is nothing but trying out all possible trying out every possible set of keys, and on an average, we have to search with at least half of all the possible keys in order to find out what is the secret key which is being used in the encryption scheme. So for different types of key sizes, so this table shows the time required for decryption. The DES, which was a commonly used famous encryption algorithm, which has a 56-bit key size. And then you have the AES, which has a 128 bits key size. And then you have the triple DES, which has a 168-bit key size. For DES, the time required at 10^6 decryptions per microsecond is 10.01 hours. And for 168-bit key size, the time required at 10^6 decryption per microsecond is 5.9 into 10^30 years. For search, if the possible key combinations are higher, then it's impractical to search all possible set of key values. So that is all about the basics of cryptographic attacks and about the symmetric cipher model. Thank you.